In this video, I'll talk about the relationship between frequency, wavelength, time period, and velocity. So if you look at the light is a wave. In fact, it is an electromagnetic wave. So what does the electromagnetic wave means? That means it doesn't require any medium to travel. As an example, light comes from sun to the earth. And if you look at the vast space between the sun and the earth, it's empty. There's nothing in between. It's a perfect vacuum somewhere. But still, the light comes from the sun to the earth. This clearly tells you that there is no medium, or it doesn't require a medium to go from one point to another point. That's the electromagnetic wave. But there are other waves which requires a medium. For example, the sound. The sound requires a medium. And in this case, as I'm talking, some other people are listening. And how does it happen? Because there is an air between, air as a medium. If there is no air, then you cannot communicate with your persons, with another person, with your friend. This means in order for the sound wave to propagate from one point to another point, it requires a medium. All right. So what is the relation between the speed, frequency, and wavelength and time period? So let's talk about the speed. The light speed is dependent on the medium in which it is traveling. For example, the sound, for example, the light has the greatest speed, the maximum speed when it moves through air or vacuum. But when it goes into medium, the light slows down. That means the speed is reduced. And the same thing happens for the sound wave. It is medium dependent. And as the speed changes, so is its wavelength. So let's talk about this one here. So here you have to find the wavelength of a wave. The time period is given, that is 20 seconds, and the velocity is 40 meters per second. So let's write down all the information. The lambda, we have to find out. The time period is given, and you have to find out the speed. The speed is given, the 40 meters per second. All right. So here I'm interchangeably using the speed and the velocity. It's exactly the same thing. A speed at any point is just the magnitude of the velocity. So, which is given 40 meters per second. All you have to remember in order to solve this kind of problem is the relation. So the speed is given by frequency times the wavelength. Okay. V stands for the speed, F is for the frequency, and this is for the wavelength, the lambda. This is pronounced as lambda, and this tells you the wavelength. And frequency, the frequency is 1 over t, that's the time period. So just to make you a little bit more information about frequency, the frequency means how many complete oscillation it makes in 1 second is the frequency. And the time period means how much time it requires to make one complete oscillation is the time period. Okay. So now I will talk about all those things in a separate video. For now, we'll just focus on to this equation here. All we need is this equation. To solve this problem. Okay. So we have speed as it is. The frequency is given by 1 over time period. Here is another equation here. Let me highlight this one. Okay. And we have to solve for the lambda, that is the wavelength. So the lambda will be simply equal to speed times the time period. All the information is given. Speed is 40. The time period is 20. If you multiply these two numbers, you will get 800 meters. So that means the wavelength is 800 meters. Okay, and remember the unit of wavelength is always in meter. It's a physical length. The time period is in second and the speed is in meter per second. So it's a quite a straightforward thing, but in order to understand, please, in order to understand the concept of all these terms, frequency, wavelength, time period, and velocity, please watch my other videos. Thank you so much. And if you have any other question and comments, write down in the comment section below. And do not forget to like, share, and subscribe the channel. Thank you.